All right, so we're going to look at section 9.6, which is on counting principles. It's part of probability. It's part of the probability models that we're going to look at today. So one of the first models that we're going to look at is our permutation model. And permutation models are used when the order of things matters. Okay, so when the order of things matters, we use permutations for a probability model. It's represented by n permutate r, where n is your number of choices and r is the things that you're choosing. So like if we were talking about a horse race and we had 8 horses and we wanted to see how many would come in for second or third, then this would be like 8 permutate 3 because we have 3 options. Okay, and so then you have n factorial divided by n minus r factorial. Okay, everybody got that one? Okay, so then the second probability model that we're going to look at today is combinations, and that's when order doesn't matter. Okay, and combinations are used way more often because most of the time order doesn't matter. So like an example of a combination might be if you were looking at a deck of 52 cards and you wanted to figure out how to get 4 of a kind out of those 52 cards. So 52 combinate 4. And so your combination model is n factorial divided by n minus r factorial times r factorial. Okay, so we look at that probability model 8 permutate 3. Our permutation model is n factorial divided by n minus r factorial. And so n is the number you start with, r is the choices that you're choosing. So if I plug all that stuff in, then I end up with 8 factorial divided by 8 minus 3 factorial. So if I simplify 8 factorial, it stays the same. 8 minus 3 becomes 5 factorial. 8 minus 3 is 6. Oh, 6. I'm like, I'm missing something. Okay. All right. So then, yeah, if you simplify 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Did you go the other way? Okay. I was going to say, I think you get a number bigger than 6. And then 5 times 4 times 3 times 2 times 1 would be 5 factorial. So then you cancel the things that are the same. So end up with 8 times 7 times 6. And what is 8 times 7 times 6? 336. So we would have a total of 336 different ways that we could start with 8 and end with 3. I do one more of those, 5 permutate 2. My permutation model is n factorial divided by n minus r factorial. And n and r come from my model. So I end up with 5 factorial divided by 5 minus 2 factorial. 5 factorial stays the same. 5 minus 2 is 3, so 3 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1. Cancel the things that are the same, and we end up with 5 times 4, which is 20. So there's 20 different ways to do that. Okay, then the other model we looked at that we're going to look at is your combination model. So if I have 5 combinate 3, my combination model is n factorial divided by n minus r factorial divided by r factorial. And n and r are the same. So I get 5 factorial divided by 5 minus 3 factorial times 3 factorial. So if I simplify, 5 factorial, 5 minus 3 is 2 factorial divided by 3 factorial. You can't combine them that way. So no, we can't combine them, the 2 and the 3 into 5. So 5 factorial is 5 times 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. And 3 factorial is 3 times 2 times 1. So if I cancel the things that are the same, end up with 5 times 4 divided by 2 times 1. What's 5 times 4? 20. What's 2 times 1? What's 20 divided by 2? 10. So there'd be 10 different ways to do that. All right, you guys want to do one more or 2 more? One more? Okay. Okay, let's do this one. All right, so 52 combinate 5. So I end up with n factorial divided by n minus r factorial times r factorial. So I end up with 52 factorial divided by 52 minus 5 factorial times 5 factorial. Well, 52 minus 5 is 47. So I get 47 factorial, 5 factorial. And so if I go to simplify, 52 times 51 times 50 times 49 times 48 times 47 factorial. I'm going to stop there because I know that I have a 47 factorial in my denominator, so that I can cancel them with. So 47 factorial, and then 5 factorial is 5 times 4 times 3 times 2 times 1. So my 47 factorial and my 47 factorial cancel. And so if I simplify my numerator, 52 times 51 times 50 times 49 times 48, what am I going to get? It's a really big number, yeah. What is the number? $200. And 5 times 4 times 3 times 2 times 1 is 120. Okay, so take your very large number and divide it by 120 and tell me what you get. So it would be 2,598,960 different ways to take 52 cards and get 5 different combinations of those cards. Okay. So we're going to work through combinations and permutations 29 through 38 and 51 through 60.